All right, before we get back to what we were doing with congruent triangles, because we still have some more stuff to cover in that unit, I wanted to come back around to transformations really quick. And we're going to just start with doing a little bit of transformation review to start the semester. Two reasons for this. One, when we look at the TE21 benchmark data, for all the classes at all the schools, virtual and traditional throughout the county, translations was the thing that people had the most trouble with. And I think part of that was you took that test before we were completely finished with transformations. But that does seem to be something that comes up a lot on TN Ready, and it seems to be something that's one of the trickier things to do in geometry, in my opinion. The second reason is that there is a relation between transformations and what we've been doing with congruent triangles. I mentioned that briefly in one of our sessions right before the break, but I wanted to come back around to that. So one of the main things I want to focus on as we briefly review transformations is this term that I probably should have brought up earlier but didn't, and that is rigid motion. That's a really important vocabulary thing that I want to make sure you're aware of, so make sure you get this down wherever you keep your notes. A rigid motion is a transformation that will move a figure without changing its shape or size. And we had 4 transformations that we dealt with, and 3 of them are rigid motions. And we've talked about that some, because one thing we learned is if you do a translation, a reflection, or a rotation, all the side lengths and all the angle measurements of your shape stay the same. So if you look at this translation going from the dark purple to the light purple, all the sides still are exactly the same length. They do not change at all. The shape is exactly the same. All the angles are the same. Same thing with the reflection and with the rotation. So translations, reflections, and rotations are called rigid motions. And if you think about the word rigid means that, like, if you're rigid, you're like frozen in place. You can't move. Somebody can move you, but when they move you, you will still be locked in the same position you were in before they moved you. So no matter how they move you, you'll still look exactly the same. So rigid motions means to move something without changing its shape or size. The one that we did that's not a rigid motion is dilation. Because when you dilate something, yeah, you can change its location, its position, but you also change its size. So it's not a rigid motion. So of the 4 we did, 3 are rigid motions and 1 is not. So just keep in mind, if it's a rigid motion, the size won't change. And that's the way you remember that dilation doesn't really fit there. There's a little statement here, and I'm going to actually get to this on the next slide here, because this is the other thing I wanted to go over. If 2 figures are congruent, then you will always be able to perform either a rigid motion or a series of rigid motions to match them up with each other, to get where they are exactly lined up on top of each other. And the converse of that is also true. If you can do rigid motions to match up one figure with another figure, they have to be congruent. So if you look at this diagram here, we have a triangle ABC. And we have this dotted line triangle. And if you look at the dotted line triangle, what they did here is they reflected triangle ABC over the x-axis. And they got this dotted line triangle. Then they took the dotted line triangle and they translated it they translated it 6 to the left and up 1. So 6 to the left and 1 up. So what they did for ABC is they translated it or they reflected it, I'm sorry, then they translated it. And if you reflect it and translate it and you end up with this triangle right here, or you end up completely lining up with this triangle, that tells you that triangle ABC must be congruent to triangle DEF. So those are just the two things I wanted to cover. One, that vocabulary, rigid motions, which refers to reflections, rotations, and translations. Make sure we have that vocabulary because it will come up on things that we do. And then the second thing is how is this related to congruency? And the idea is if you perform a series of rigid motions on a figure, the figure you end up with will be congruent to the original. And if you can take a figure and do a bunch of rigid motions, a bunch of reflections, rotations, translations, and line it up with another figure, those figures have to be congruent. So that's what I wanted to go over to start off the semester. So there you go.